Welcome to the Joy of Architecture. Today we're peeling back the layers on a system that's quietly revolutionizing how modern applications decide who gets to do what. OpenFGA. Our mission, as always, is to take a stack of articles, research, and our own insights and distill the real essence for you. We're going beyond the jargon to uncover why OpenFGA isn't just another tech tool, but maybe a fundamental shift in securing your applications, and maybe find some insights that might just surprise you.
And we've got some fantastic material today, I think.
Hey,
Tracing OpenFGA's lineage from Google's internal Zanzibar system to its current open source form. We'll try to demystify its core architecture, explore its power through, real-world scenarios, and ultimately help you grasp not just what OpenFGA is, but why it's becoming so important for robust, scalable application security.
Okay, so let's set the stage. Thinking about access control, that fundamental question, who can do what with what? For years, we relied on models like role-based access control, RBAC.
Right, RBAC. It's straightforward, You assign roles like admin or editor to users, and those roles carry specific permissions. It's pretty effective for simple hierarchical organizations. But as systems grew, it started buckling under the weight of what people call role explosion.
Role explosion, yeah, I've seen that. Right.
Where you end up with hundreds, maybe thousands of roles. It makes management a nightmare, frankly, and you start getting unexpected security blind spots.
And then attribute-based access control, ABAC, came along. That offered more dynamism, didn't it?
It did. Instead of just roles, it uses policies that evaluate attributes of the user, the resource, the action, even the environment, like a time of day.
So something like, only users with the analyst attribute can see financial reports during business hours. Sounds super flexible.
It is flexible, definitely.
Yeah.
But its power comes with significant complexity. In implementation, sure, but especially debugging. When your permissions are scattered across multiple attribute checks, figuring out why someone got access or didn't can become this huge forensic investigation. A lot of teams get bogged down in just maintaining it.
Okay, so that brings us to relationship-based access control, or ReBAC. This is where OpenFGA really comes in, you're saying.
Exactly. ReBAC defines permissions based on the relationships between entities.
So how does that work in practice?
Well, you're no longer just an editor in some general sense. You can edit a document because you own it, maybe. Or you're a member of a team that has access to the folder that contains that document.
I see. It's about the connections.
Precisely. It's transformative for collaborative applications where permissions are inherently social, hierarchical. It models reality in a way RBAC and, frankly, ABAC just can't without a ton of effort.
And here's the maybe subtle but profound shift. In modern apps, microservices especially, embedding authorization logic everywhere just leads to duplication, right? Inconsistencies.
Oh, absolutely. And a security posture that's constantly shifting, hard to pin down.
So a centralized authorization service isn't just a nice-to-have anymore.
No, it's becoming a necessity, especially for consistent, low-latency decisions across all those distributed systems.
So for applications like, say, Google Docs or multi-tenant SaaS platforms or even complex internal tools, you need that fine-grained authorization that handles these intricate connections.
ReBAC models these relationships naturally. It moves beyond just who you are or what attributes you have to how you are connected to the resource. It's letting the data's own structure define permissions.
And that's the gap OpenFGA fills.
That's exactly the gap OpenFGA fills, yes.
Okay, so given all that context, what exactly is OpenFGA? Let's nail that down.
So OpenFGA is a high-performance open-source authorization engine designed specifically for fine-grained authorization. Its primary function is really to externalize that authorization logic out of your application code.
Externalize it. Okay.
Yeah. Instead of hard-coding permission checks everywhere, you define a permission model, you store your relationship data, and then your application just asks OpenFGA a simple question. Can user X view document Y?
That sounds much cleaner.
It is. It's about centralizing and simplifying what can be a very complex problem.
And it has quite the origin story, right? This wasn't just like built from scratch in a vacuum.
No, not at all. OpenFGA's genesis is really the 2019 Yosenix paper, Zanzibar, Google's consistent global authorization system.
Ah, the Zanzibar paper. Heard of it.
Right. It detailed Google's internal system, which handles permissions for hundreds of products. Think Drive, YouTube, at immense scale. We're talking trillions of access control lists, millions of requests per second. Zanzibar prioritized correctness, flexibility, and crucially extreme performance. often under 10 milliseconds for most checks.
Wow. Okay, so Auth0, which later got acquired by Okta, they saw the power in this battle-tested Google concept and decided to open source it.
That's the story, and now it's a CNCF sandbox project.
Cloud Native Computing Foundation, right?
Yeah, which means it's on a path to becoming a vendor-neutral, community-driven standard.
And how does it differ from Zanzibar itself? Because Zanzibar was internal Google tech.
Right. Zanzibar was tightly coupled to Google's proprietary infrastructure, like their globally consistent spanner database. OpenFGA kind of democratizes it. It abstracts away those dependencies. It offers pluggable database backends. PostgreSQL, MySQL are common. It treats users generically, makes it adaptable to really any tech stack.
So it's like Zanzibar for the masses.
That's a good way to put it, yeah. Its core goals are just blazing speed for checks, scalability for projects big and small, and open collaboration through the CNCF. This makes it really ideal for things like multi-tenant SaaS, collaborative platforms, securing fine-grained API features.
Okay, how does OpenFGA compare to other authorization solutions developers might already know, like Open Policy Agent?
Yeah, that's a really key distinction to make. OpenFGA is data-centric. Its logic comes from the model you define and that dynamic graph of relationship data, the tuples. OPA, Open Policy Agent, is policy-centric. The complex logic lives in its ReGO code.
Right.
So while OPA is very general purpose, it excels in infrastructure security. Think Kubernetes admission control, API gateway policies, that sort of thing. OpenFGA is purpose-built, optimized specifically for RBAC in application authorization.
So they could even be complementary.
Oh, absolutely. Often they are. OPA secures your infrastructure. OpenFGA secures your application's business logic.
What about others, like Casbin?
Casbin is often used as a library, embedded directly in the application. It's versatile. OpenFGA is typically designed as an external standalone service.
And AuthFGA.
That's simply the managed commercial SaaS version of OpenFGA. Same engine, but Okta handles all the operational heavy lifting for you.
Got it. Okay, let's dive into the core concepts. To really get OpenFGA, we need its building blocks. What's the atom of data here?
That would be the relationship triple. The really simple triplet. User relation object.
Okay.
Example. User.an. Viewer document.roadmap. That just means user an is a viewer of the roadmap document.
These tuples are basically the edges in your permission graph. They describe the actual concrete connections.
Okay, so tuples are the dynamic data connections. What defines the rules? It's a sort of schema for these connections.
That's the authorization model. It's written in OpenFGA's own modeling language, which is designed to be human readable. It defines your types first, like user, document, folder, and then the possible relations between them.
Relations like owner or viewer.
Exactly. And relations can be directly assignable, like you'd say owner, user, or, and this is where it gets really powerful, they can be computed or implied.
Computed or implied.
Yeah.
That sounds like where the real magic happens. How does that grant permissions?
It means you can define relations based on other relations. Create a chain, essentially.
Like how? Like you could define viewer, owner, or editor. So if you're an owner or an editor, boom, you're implicitly a viewer. You don't need another tuple saying so.
Okay, that saves data.
It does. And even more powerful is something called tuple to user set, or TTU.
Yeah.
You might write define viewer. Viewer from parent.
Viewer from parent. What does that do?
It means you're a viewer of an object if you're a viewer of its parent. This is exactly how you model hierarchical inheritance. Think folder permissions cascading down to the documents inside. Super common requirement.
Ah, that makes perfect sense for complex structures. Okay, so you've modeled all this. How do my applications actually talk to OpenFGA to get decisions?
It exposes some pretty simple APIs. The check API is the workhorse, you ask. Is access allowed for this user on this object with this relation? And it just comes back true or false.
Simple enough. What else?
There's list objects. That answers the question, what documents can this user view? Which is crucial if you want to build a UI that only shows things the user actually has access to.
Right, you don't want to show links they can't click on.
Exactly. And then there's the expand API. This one's invaluable for debugging. It answers the question, okay, why is access allowed? By showing you the full relationship graph, the decision tree that led to true.
That expand API, that sounds incredibly useful for troubleshooting. I mean, how often have you spent hours trying to figure out some complex permission thing?
It's a total game changer for debugging, honestly. Trying to explain why someone doesn't have access in a complex RBAC or ABC system can be maddening. Expand shows you the path or lack thereof.
Okay. Speaking of potential headaches, evolving the schema, Authorization models change. How does OpenFGA handle changes to its models without, causing chaos in production?
That's a great point. OpenFGA treats authorization models as immutable,
Immutable, meaning?
meaning when you deploy a new model, maybe with changes, it gets a completely new, unique ID. It doesn't overwrite the old one.
Okay.
This is a core safety feature, really, especially for mature engineering teams. It prevents accidentally breaking existing applications that rely on the old model structure. Rollbacks are as simple as just pointing your app back to an older model ID.
So the best practice is always pin your application to a specific model ID in its API calls.
Absolutely. Always pinned to a specific model ID. Gives you stability.
What about data consistency? Google's Zanzibar is famous for its global consistency guarantees using things like Zookeys, these opaque tokens. How does OpenFGA handle that, given it runs on more common infrastructure?
Yeah, Zanzibar's approach relied heavily on Spanner's global consistency. OpenFGA, being designed for PostgreSQL or MySQL, offers a more pragmatic trade-off. It gives you options. There's minimized latency, which is the default. It uses a cache, might be slightly stale, but it's fast. Then there's higher consistency. This bypasses the cache, goes straight to the database for the absolute freshest data, but naturally it incurs higher latency.
So you choose based on the use case?
Exactly. Caching is pretty critical for performance in production, and you can configure its behavior.
And quickly, what are the underlying components? What makes it tick?
It's a Go-based API server. Pluggable storage backends, as we said, PostgreSQL, MySQL for production usually. The evaluation engine is the brain, really. It traverses that relationship graph to make the decisions. And there's also a read changes API that gives you a chronological log of all the tuple changes, creations, deletions, super valuable for audit trails, or syncing permission changes to other downstream systems.
Okay, let's shift from the theory to practice. How do you actually design an authorization model effectively with OpenFGA? Is it just like designing database schemas?
It requires a bit of a shift in thinking, I'd say. Instead of trying to force-fit generic rules onto everything, you model your application's domain logic directly as relationships. You think about how your users naturally interact with your data, what connections matter.
Can you give us some concrete examples? Like how would you model something like Google Docs style sharing?
Yeah, absolutely. For document sharing, you define types like user, document, and maybe folder. You can model concentric roles, owner implies editor implies viewer, that we discussed. And that hierarchical inheritance using TTU is key there. If a user is a viewer of a folder, they automatically become a viewer of documents inside that folder.
Makes sense. And public access.
That's often modeled using a special wildcard user, like user. So you might have a tuple,
Yeah.
user viewer document.public doc. You use that carefully, obviously.
Yes. What about something more complex, like a GitHub-style repository system? Teams, organizations, nested permissions.
Yeah, that's a great fit too. You can model nested teams. A team can have other teams as members, right? And repository permissions can be granted to individuals or to teams. And organization-level inheritance is powerful there too. Maybe an organization admin implicitly becomes an admin on all repositories within that organization. OpenFGA handles these recursive relationships pretty elegantly.
Okay. And for, say, a multi-tenant SaaS platform, data isolation is absolutely critical there. How do you ensure tenant A's users never see tenant B's data?
Yeah, that's paramount. The best practice is usually to model the tenant or the organization as a top-level object type itself. Then every resource, like a document or a project, would have a mandatory tenant relation connecting it back to its owning tenant. For example, document.doc123 might have a relation tenant pointing to tenant.abc.
So the relationship itself enforces the boundary.
Exactly. When OpenFGA traverses the graph for a check request, like can user from tenant A see doc123, any path to that document must go through the correct tenant object, tenant.abc. If the user isn't related to tenant.abc, the check fails. Isolation is inherent in the graph structure.
That's clever. Are there any critical best practices or, gotchas to keep in mind when actually building these models?
Yeah, a few important ones. First, a good rule of thumb. If an end user can define or assign something like adding someone to a custom project role they created, that should probably be dynamic data, the tuple. But if it's a built-in application concept, like a system-wide admin role that users can't change, that belongs in the model itself as a defined relation.
So distinguish between user-managed assignments and system-defined structure.
Exactly. And related to that, try to separate roles, the things you assign, like owner, editor, member from permissions. The specific actions your application checks, like can delete, can rename, can invite.
How does that help?
The model then defines the permissions as computed properties of the roles. So define can_delete.owner. This creates a really valuable layer of abstraction. If your business logic changes later, maybe editors can now delete things. You only update the model, define can_delete.owner or editor.
Yeah.
You don't have to change your application code that just checks can_delete.
Ah, nice decoupling. Any warnings, like about those wildcards or deep hierarchies?
Yeah, user is powerful for public access, but use it with caution. And remember, it typically only works in the user part of a tuple. And while recursion is supported for nested groups or folders, extremely deep or wide hierarchies can impact query performance. So, design models to reflect reasonable real-world constraints and maybe tune server limits if needed.
And caching. You mentioned it's critical for performance. How does that feed back into design and usage?
Right. For production, low latency is key, so caching is essential. You'll mostly use the minimize latency consistency setting for check calls, letting the system leverage its cache. But for those critical read after write scenarios, like immediately after you grant someone permission, you need to check it. You might use high header consistency for that specific check to bypass the cache and ensure freshness.
And operationally.
Operationally, it's usually better to deploy with fewer, larger server instances rather than many small ones. It just maximizes the chance that a request will hit a server with the relevant data already cached. Better cache hit ratio?
Okay, makes sense. So once the model's designed, how do you actually plug OpenFGA into existing systems, the practical integration part?
Well, OpenFGA provides official SDKs for most popular languages: Go, Node.js, Python, Java, .NET, and so on. The standard best practice is to initialize the client object just once when your application starts up, and then reuse that same client instance for all subsequent requests. It's much more efficient than creating a new client for every single permission check.
And how does it fit into microservice architectures? Those often have their own authorization headaches, right, for services calling other services.
Yeah, it's actually an ideal fit there because OpenFGA externalizes the authorization logic. It decouples it cleanly from your business logic. So a typical flow: your microservice gets an authenticated request. Before doing any real work, it makes a quick check call to the OpenFGA service. If OpenFGA says allowed true, then it proceeds with its business logic.
So it stops the mess of having permission checks scattered everywhere.
Exactly. It consolidates your authorization logic into one place, managed by the model and the data in OpenFGA, rather than having slightly different implementations creeping into every service.
Okay. Now, OpenFGA handles authorization who can do what. It doesn't handle authentication proving who you are. How does it play with identity providers like Auth itself or Keycloak, Okta, etc.?
Right. You absolutely pair it with an identity provider, IDP. The IDP handles the login, authenticates the user, and typically issues something like a JWT token containing a user ID. That user ID is then extracted from the token and passed along to OpenFGA in the check request's user field.
So the IDP says who they are, OpenFGA says what they can do.
Precisely. And for some IDPs like Keycloak, there's even community-driven tooling like an event publisher that can automatically synchronize user creations or group membership changes from Keycloak directly into OpenFGA's tuples. That helps keep the data aligned.
That sounds useful. I also heard about something called contextual tuples. What's that about?
Yeah. Contextual tuples are kind of a pragmatic feature, maybe an escape hatch. Sometimes you might have information in your JWT token itself, like a list of groups the user belongs to. Instead of having to sync all those group memberships into OpenFGA beforehand, you can actually pass those group relationships along with the check request.
As temporary tuples.
Yeah, exactly. OpenFGA treats them as if they were stored tuples, but only for the duration of that single check request. It can reduce the need for complex, real-time data synchronization pipelines for certain types of rapidly changing or token-based data. The trade-off is that the permission is only as fresh as the token, of course.
So it sounds like the core operational challenge then is keeping OpenFGA's relationship data, all those tuples, accurately in sync with your application's actual state.
That is arguably the single greatest operational challenge when implementing any Zanzibar-style system like OpenFGA. If that tuple data becomes inaccurate or stale, you risk serious security flaws, either denying access to people who should have it, or worse, granting access to those who shouldn't.
What are the strategies for keeping it in sync?
Well, there are a few common patterns. The simplest is maybe dual writes. Your application writes to its own database, and then immediately writes the corresponding tuple change to OpenFGA. Simple but brittle. If the second write fails, things get out of sync.
Right.
A more robust approach is often event-driven synchronization. Your application emits events when relevant data changes, like a user joining a team, And a separate service consumes these events and translates them into OpenFGA tuple rights. This decouples the systems.
Okay.
Or even more advanced, using change data capture CDC tools to directly tail your application database's transaction log and automatically propagate relevant changes to OpenFGA. That completely isolates the application from needing to know about the authorization system's data needs.
Okay, let's talk deployment. Getting OpenFGA into production. If you're self-hosting, what are the typical options?
It's really built for modern containerized environments, so running it with Docker is straightforward. Often people use Docker Compose for local dev or simpler persistent setups, pairing it with a PostgreSQL or MySQL container. For Kubernetes, which is very common for production, the official Helm chart is definitely the recommended method. It handles the deployment configuration, service creation, all that complexity for you.
And scaling. Authorization checks need to be fast. What do you need to consider for high-performance use?
Yeah, scaling involves thinking about both the OpenFGA server instances themselves and, critically, the database backend. PostgreSQL is probably the most mature and commonly used production backend right now. OpenFGA allows you to configure separate read and write database URIs so you can point read queries, like check and list objects, to read replicas to distribute the load.
Standard database scaling patterns.
Exactly. And it's crucial to tune your database connection pools appropriately, both on the OpenFGA server side and the database side. OpenFGA also has settings for concurrency limits. These act like circuit breakers to prevent a few extremely complex runaway queries, maybe involving very deep graph traversals, from consuming all available resources and impacting overall service availability.
Like a safety valve.
Precisely. And remember what we said about caching. Use fewer, larger servers to maximize cache hit rates if you can.
What about monitoring? Keeping an eye on it once it's running.
OpenFGA has really good first-class support for OpenTelemetry. It can export traces, metrics, and logs in standard formats. It's highly recommended, I say essential, to enable metrics and tracing in production. This gives you deep visibility into request latency, error rates, query performance characteristics, cache hit rates, all the key indicators.
And if you're using database replication,
Then you absolutely need to monitor replication lag as well to understand potential data staleness.
and security hardening. What are the non-negotiables before going live?
Right. First, API authentication. OpenFGA supports pre-shared keys, or better, OIDC, for authenticating clients calling its API. You need something. Enable TLS for encrypted communication between your apps and OpenFGA, always. Critically, disable the web playground in production environments. It's a fantastic development tool, but it exposes internals and is a security risk in prod.
Good tip.
And, as mentioned before but worth repeating, never store. Personally identifiable information, PII, directly in tuples. Use opaque, non-guessable application-specific IDs for users and objects. Protect that user privacy.
So if you self-host, backup and recovery are entirely on you.
Exactly. The operational burden significantly shifts towards managing your chosen database backend effectively at scale. That includes robust backup strategies, point-in-time recovery capabilities, disaster recovery planning. All that falls on your team.
Which is a key difference compared to using a managed service like AuthFGA.
Absolutely. With the managed service, the vendor handles all of that operational complexity, providing SLAs, support, etc. It's the classic build versus buy trade-off.
Okay, let's talk governance. Auditing, compliance. These are huge in enterprise settings. How does OpenFGA help here?
OpenFGA provides specific APIs geared towards auditing. The Read Changes API, which we touched on, gives you that immutable chronological stream of all tuple creation and deletion events. This is basically your foundation for a definitive audit trail. You can see exactly what permissions changed, who changed them, and when.
And for understanding why a decision was made at a specific point in time, not just that a tuple changed.
That's where the Expand API comes back into play. It's not just for debugging. It helps answer the compliance question. Why does user Alice have viewer access to this document right now? It provides that full decision tree, tracing the permission back to the specific source tuples and model rules that grant it. Invaluable for compliance verification and also for incident response if something goes wrong.
So you get clear data lineage for permissions.
Yes, the combination of the static versioned authorization model and the dynamic relationship graph stored as tuples allows for really clear data lineage. You can programmatically demonstrate, for instance, Alice has viewer access to doc.secret because she's a member of team.auditors, which has the viewer relation on folder.compliance, which is the parent of doc.secret. It lays it all out.
How does this integrate with existing tools like SIEM systems or centralized logging?
OpenFGA outputs structured JSON logs. which can easily be ingested by pretty much any modern SIEM or logging platform, Splunk, Datadog, ELK stack, you name it. Alternatively, you can build a dedicated service that periodically pulls the read changes API, transforms those tuple change events into a standardized audit event format your organization uses, and forwards them to your central audit system.
This all sounds very much like it promotes a policy as code approach. Is that intentional?
Oh, absolutely. It aligns perfectly with policy as code principles. Your authorization model is a declarative text file. Your tests, which define expected outcomes, FGA model test, are also text files. This means they fit perfectly into Git repositories. All changes to your authorization logic can go through your standard software development lifecycle, pull requests, peer reviews, automated testing, full Git history.
So you can integrate model testing into CI/CD.
Definitely. The FGA model test command can be run in your CI/CD pipeline to automatically validate any proposed changes to the model, preventing regressions or accidentally insecure deployments before they hit production. And the immutability of models adds another layer of safety. New versions get new IDs, they don't overwrite old ones, making deployments and rollbacks much safer.
And for large organizations.
For larger setups, OpenFGA supports modular models, allowing different teams to potentially own and evolve different parts of the overall authorization policy independently, but still compose them together.
Okay, beyond just correctness, performance is obviously critical for an authorization system. How do you actually ensure OpenFGA performs well under real-world load?
Yeah, benchmarking is crucial. There was an interesting study published by Valcris, for instance. They benchmarked OpenFGA for their use case and found lookup throughput was around 1,500, 1,700 operations per second per instance, which was plenty for their production needs. But, and this is key, every organization really needs to conduct their own benchmarks using their specific models and realistic data shapes and volumes. Performance depends heavily on the complexity of the model and the graph.
So once you have a model, how do you really stress test it? Especially with potentially large, complex relationship graphs.
Right, you need to go beyond simple benchmarks. Deploy OpenFGA in a production-like environment. Populate it with a large volume of tuples that mimic your expected production scale and distribution. Then, simulate high concurrency traffic hitting the check, list objects, and expand APIs. Monitor those key performance indicators we talked about. API latency, P95, P99, error rates, CPU memory utilization on both the OpenFGA servers and the database. This is how you find bottlenecks before your users do.
What about detecting conflicts, not syntax errors, but logical ones, where maybe a change unintentionally grants someone access they shouldn't have?
Good question. The model compiler catches syntax errors, obviously. But those logical conflicts are best caught by having a really comprehensive test suite using SGA model test. Critically, your test should include negative assertions. Don't just test that user Z cannot do W. These negative tests are vital for catching unintended side effects of model changes.
Are there specific tools to help with visualizing or validating models during development?
Yeah, the ecosystem is growing. There's the official OpenFGA VS Code extension, which gives you syntax highlighting, basic validation, helpful stuff while you're writing the model. There's the OpenFGA Playground Web UI again, great for rapid prototyping and experimenting, but remember to disable it in production. And community projects are popping up, like OpenFGA Studio, which offers more enhanced UIs, sometimes with interactive graph visualizations and better ways to manage tuples during development.
And of course, the FFGA CLI is your command line tool for scripting checks, tests, and integrating validation into CI/CD pipelines.
Okay, so what happens when something inevitably does go wrong in production? How do you approach debugging authorization failures?
Depends on the type of failure. If it's a logical failure like your app gets an unexpected allowed false result, your first stop should always be the expand API. Run the same check through expand, and it will show you the exact decision tree, revealing why the expected relationship path didn't resolve or why an unexpected one did.
Okay, that handles logic errors. What about performance issues? High latency. For performance problems, your best friends are OpenTelemetry traces and metrics. Traces can help you pinpoint exactly where the time is being spent. Is it a slow database query? Is it complex computation within the evaluation engine? Metrics give you the broader picture of resource usage and request rates.
And system failures, like HTTP 500 errors or timeouts.
For those, you need to check the structured logs from the OpenFGA server itself, as well as system and database metrics. Look for signs of resource exhaustion, running out of memory, CPU pegged, maybe database connection pool exhaustion. There was a reported issue, for instance, traced simply to running out of database connections under load. Standard operational debugging applies.
OpenFGA sounds incredibly capable, but as you said, it's not the only game in town. Let's revisit that comparison with its conceptual parent, Zanzibar. What are the key trade-offs again?
Right. While OpenFGA is directly inspired by Zanzibar, it makes pragmatic trade-offs precisely to enable broader open implementation. Zanzibar is tied to Google's specific proprietary infrastructure, especially Spanner, for global consistency. OpenFGA abstracts the storage layer, letting you use commodity databases like PostgreSQL or MySQL. Zanzibar provides stronger, built-in consistency guarantees using those Zookeys. OpenFGA offers tunable consistency. You can choose between potentially stale cached reads for speed, minimize latency, or direct database reads for freshness, higher consistency. It's generally easier to implement and manage OpenFGA on standard databases, but you might give up some of Zanzibar's strictest consistency guarantees by default.
Makes sense. And that build versus buy decision again. Self-hosted OpenFGA versus the managed AuthorFGA offering. What's the core difference for someone listening and deciding?
Yeah, it boils down to operational responsibility. The core authorization engine, the modeling language, the APIs, they're identical. It's the same open source code. The difference is who manages the infrastructure. Self-hosting means you handle everything. Setting up high availability, failover, scaling the servers in the database, security patching, monitoring, alerting, backups, disaster recovery, all of it. AuthFGA, the managed service, abstracts all that operational complexity away. You pay a recurring fee, and they handle the infrastructure, offer SLAs, provide dedicated support. It's fundamentally a trade-off between having full control versus offloading the operational burden.
Right. Do you want to run an authorization service or just use one?
Exactly. That's the question to ask.
It's always insightful to see how these projects are actually used in the real world. What kind of adoption patterns are emerging for OpenFGA? Are there public case studies yet?
Specific, big-name public case studies are still emerging, as it's relatively young as a mature open-source project. However, community discussions, blog posts, and conference talks reveal common themes. You see developers prototyping centralized authorization systems, often highlighting the challenges around effective model evolution across different teams, and especially building those robust data ingestion pipelines to keep tuples in sync. It underscores that the operational aspects, like data synchronization, are often just as challenging, if not more so, than the core modeling itself. There's a good practical case study from BrainHub, for example, where they detailed building authorization for a cloud drive application, showing how they model ownership, sharing hierarchical permissions using OpenFGA concepts.
Interesting. And for organizations that already have an authorization system, maybe a legacy RBAC setup, how do they typically approach migrating to something like OpenFGA? Is it a big bang replacement?
Definitely not recommended as a big bang. The most successful pattern seems to be an iterative, gradual migration, often following a kind of start course, go fine approach. First step is often just replicating your existing, relatively coarse-grained RBAC rules within OpenFGA, get the basic integration working, solve the initial data sync challenges with a simpler model.
Get the plumbing right first.
Exactly. Then a really critical phase. Run OpenFGA in shadow mode. Your application queries both the legacy system and OpenFGA for permission checks. You enforce the decisions based on the old system, but you log the results from OpenFGA and compare them.
Why is that so important?
It's critical for validating the correctness of your OpenFGA model and data against the legacy system without impacting users. It also lets you measure the performance impact of adding OpenFGA calls. Once you have high confidence from the shadow mode comparison, then you cut over to enforcing decisions based on OpenFGA.
And then you start refining the model.
Yes. After the cutover, you can iteratively enhance the OpenFGA model to take full advantage of its ReBAC capabilities, introducing finer-grained permissions, relationships, and hierarchies that weren't possible in the old system.
What about community contributions? You mentioned it's CNCF. How is the broader ecosystem developing?
The community is definitely growing and active. You see contributions coming from individuals, but also from other companies using OpenFGA, like Grafana Labs, for example. This has led to some valuable ecosystem tooling emerging, like that Keycloak event publisher we mentioned for IDP integration, or visualization tools like OpenFGA Studio. And the discussions in the community Slack and forums are really helping to solidify best practice architectures, especially around things like multi-tenancy modeling and event-driven data synchronization patterns. It shows the power of open collaboration.
So looking ahead, what's next for OpenFGA? Where's the project heading?
It's under very active development. Recent features we've seen include things like that batch check API for better performance when checking multiple permissions at once, and those configurable consistency options we discussed. Minimize latency versus higher consistency.
And on the horizon, what's on the roadmap?
The public roadmap indicates a strong focus on continuing to build out enterprise-grade features. Things like enhanced observability with potentially broader open telemetry support,
There's talk of improved consistency mechanisms, possibly introducing consistency tokens similar in spirit to Zanzibar's, which would move it closer to that stronger correctness model. Also, enhanced security features, maybe native audit logging capabilities beyond just read changes, more sophisticated API authorization options, and importantly, interoperability work, aligning with emerging standards like AuthZen, which aims to standardize authorization APIs across different vendors and systems.
And its position within the CNCF is key for its future growth and adoption, right?
Absolutely. It's currently a sandbox project, but they have formally applied for promotion to CNCF incubation status. Achieving incubation would signify a higher level of project maturity, stability, and demonstrated adoption in production environments. That process also typically involves rigorous security assessments, like reviews with the CNCF Security Technical Advisory Group, TAG, further demonstrating a commitment to robust security practices. It definitely signals a project with a bright future and a strong commitment to open standards and collaboration.
Okay, so wrapping this all up, what does this mean for you, the listener, the architect, the developer out there? What's the key takeaway on OpenFGA?
I think it means OpenFGA offers a really powerful, scalable, and importantly, auditable solution for fine-grained authorization. It's especially well-suited for the kind of complex, collaborative, often multi-tenant applications we're building today. It represents a significant shift in how applications can manage permissions, moving away from potentially rigid, centralized rules or scattered logic towards a dynamic, distributed graph of relationships that often mirrors the real world more closely. The ability to model complex scenarios with a certain elegance, backed by those battle-tested concepts from Zanzibar, makes it a very compelling choice.
And the fact that it's open source and part of the CNCF, that matters too. It means it's being built for the community, by the community, aiming for vendor neutrality. It's kind of a testament to how complex problems like authorization at scale can be tackled, simplified, and shared for everyone's benefit.
So maybe the final thought for listeners is to think about your own applications. Are your current authorization rules becoming a tangled mess of roles and custom code? Could modeling the actual relationships between your users and resources unlock new levels of flexibility, clarity, and security that you haven't considered before? It really raises an important question. How much more intuitive, maintainable, and secure could your application's permissions be if they were truly reflective of how users naturally connect to resources, rather than just based on abstract labels or scattered attributes?
Definitely food for thought. We hope this deep dive into OpenFGA has given you some valuable insights and maybe sparked a few aha moments about how you approach authorization. To stay tuned for future deep dives on all things architecture, make sure to subscribe to Joy of Architecture wherever you get your podcasts. Thanks for listening.